Hello. So in this video we're going to be discussing molecular ionic and net ionic equations based on a double replacement reaction. So hopefully by now you're pretty comfortable with double replacement reactions, also known as metathesis reactions. So those two are interchangeable in how they're called. And hopefully by now you're getting pretty comfortable with predicting the products of these reactions. So if I were to give you these two reactants here, so we've got reactant 1, which is barium nitrate, this guy here, and we've got sodium sulfate, which is this guy here. So if these two were to be reacted, what would their products be? So maybe you could pause the video really quick and predict what the products of this reaction are going to be, and then unpause the video where I'll put up the answers and see maybe if you were correct in your predictions. Okay, so these are the products that you should get from your predictions, so hopefully the things you predicted match up with the actual predictions. So we have barium sulfate, which is one of our products, and sodium nitrate. However, there's one thing missing here, and it's a pretty important thing. This reaction, as of right now, is not balanced. So balancing is one of those fundamental skills that you'll need to have, and you can never assume that the reaction that you're given is balanced. So typically the first step in any of these problems might be, and probably will be, to balance. So if you could just take a few seconds, this one's a pretty quick one to do. Go ahead and see if you can balance this equation, and then unpause the video and see if your balancing is correct. Okay, so I've gone ahead and balanced this equation. And like I said, this one's pretty simple. You'll just want to put a 2 in front of this sodium nitrate. That will balance the two sodiums that come from right here, and it'll balance the two nitrates that come from here. So that is this reaction balanced. Another thing you might want to take notice of is the physical states. So our two reactants are aqueous, and that's nearly always going to be the case for your double replacement equations or your double replacement reactions, where your two reactants are going to be aqueous because you're combining them in an aqueous solution. You're reacting the two reactants in an aqueous environment, so they're both going to be aqueous. Sometimes you'll see questions where solid reactants are added to aqueous solutions. You'll want to treat those solids as aqueous because you're adding them ultimately to an aqueous environment. So that would still make both of your reactants aqueous, even though one of them started as a solid. Now notice how for the products, barium sulfate is a solid and sodium nitrate is aqueous. Well, think back to your solubility guidelines. In particular, I'm thinking of the rule of 4, which if you're a little shaky on that, maybe want to brush up on your solubility guidelines. So this barium sulfate, because it passes the rule of 4, we're going to consider this our solid. Now sometimes you'll hear this referred to as being the precipitate. Precipitate is just another word for solid. So if you see the word precipitate, think of the solid in the reaction. And you can predict what your solid is going to be based on your solubility guidelines. So in this case, sodium nitrate, for two different reasons, doesn't qualify. For one thing, sodium, anything bonded to sodium is going to be soluble, very soluble, because sodium is a group 1A metal. Group 1A metals are nearly always soluble. And then also it's bonded to nitrate, and nitrates are nearly always soluble. So this is a very, very soluble compound. So that leaves barium sulfate as our solid precipitate. And this reaction here that you're seeing in front of you is the molecular equation. So just the normal everyday equation that you're used to seeing at this point is the molecular equation. But we can take this molecular equation and break it down into a sub-equation, which is known as the ionic equation. And in the ionic equation, basically what we're going to do is we're going to break each of these compounds except the solid. So excluding the solid, we're going to break all the other compounds into their respective ions. And so what I'm going to do now is show you what that will look like for this reaction. Okay, so here is the ionic equation for this reaction. So what I've gone through and done, like I said, is broken each of these compounds, excluding the barium sulfate here, our solid. So excluding that solid, everything else has been broken into ions. So the barium nitrate gets broken into Ba2+, so the charge here is absolutely crucial. You'll need to include that. So Ba2+, plus 2 NO3-, which represents the 2 nitrates. Because remember, we have this 2 down here, which means we have 2 nitrates. So you'll want to move that 2 in front to show this as 2 nitrate molecules, which is 2 NO3-, plus 2 Na+, and that's coming from right here. So right here we have 2 Na atoms, and that's going to be right here with 2 Na+. And then we have sulfate up here. So down here we have that SO4 2-. And you'll need to know the charges for your polyatomic ions, because that will help you when you're doing these ionic and net ionic equations. And we only have one of those, so that's why we only have one here. Then on the other side of the reaction, remember, we leave our solid alone, so we don't break up the solid. We just leave it as it is. And then we'll break up the other product, which, according to our balanced equation, which is why balancing is so important. So according to our balanced equation, we have 2 Na+, which is right here, and then 2 NO3-, which is here. So this is our ionic equation, where we're showing everything as ions. And now we'll move on to the net ionic equation. And so the net ionic equation is going to eliminate everything that doesn't go into the solid. So you're going to sort of scan through these ions, and you're going to eliminate all of the ions that aren't in your solid. So the 2 ions that make up our solid are barium and sulfate. So you're going to want to eliminate everything that isn't barium or sulfate. Okay, so lastly, down here we have our net ionic equation. And what this is showing is, the formation of our precipitate, the formation of our solid. So we've eliminated everything that doesn't go into the solid. So we can eliminate nitrate, because that's not in our solid, and we can eliminate sodium, because that's not in our solid, which means we're left with the barium, the sulfate, and of course the barium sulfate. And that's what's represented here. So we've got the barium 2+ here, we've got the sulfate 2- here, and then that's going to end up making our solid, which is the barium sulfate. And this is how these ionic and net ionic equations are going to work. Because ultimately what you're doing is you're whittling down to the ions that directly make your solid. So you're taking the bigger picture and you're narrowing down to the important ions that are going to end up making your solid. Now these other ions that we crossed out have a name. They're called spectator ions. So the nitrate and the sodium here, because they're not directly involved in the making of our barium sulfate, they're still in the solution. They're still floating around in solution, even though they're not participating in the formation of our solid. And the spectator ions in this case, sodium and nitrate, are there for charge balance. So they're balancing the charge of our reaction, but they're not actually inside the solid that we made, which is barium and sulfate, making the barium sulfate. So these two would be our ions that make the solid, and the others that are left over will be called the spectator ions. So if you are ever asked to label or identify the spectator ions, just know that they are the ions that aren't in the net ionic equation. So they're the ions that don't participate in the formation of your solid. They're the leftovers. And that's about it for molecular ionic and net ionic equations. So molecular, you just want to write out your reaction, predict your products, and balance. For the ionic, you want to break up everything that isn't your solid into ions, making sure you have numbers where they have different numbers, like 2 and 2, for example. And then for the net ionic equation, you're just going to eliminate everything that doesn't go into making your solid. So eliminate the spectator ions, and you're left with the ones that make your solid. And there you go.